Okay, so this is lesson 5.8a. 5.8 is about solving log equations. Today is the basics. And your objective, you'll be successful when you can use your log properties and your conversion skills, converting a log to an exponent. And you're just going to be solving basic linear equations and quadratic equations. So they look a lot more complicated than they are. Let's review quickly how to convert a log to an exponent, log form to exponential form. So let's say I have, for example, the log of x equals 2, and I want you to convert that to exponential form. This is logarithmic form. What's my base? 10. And to convert it, 10 squared equals x. So guys, what's x equal? 100. Okay, so we'll get our equations into a form where we can do something like that, and then we can solve for x. That one was a really, really basic log equation, by the way. Okay, so we will start with this first set of examples with some things to remember. Most importantly, write this: I must check all solutions to eliminate restrictions. In other words, extraneous solutions. So they're restrictions, meaning they can't exist. They'll cause a domain error. And another term that you'll hear often is that the solution is extraneous. It's no good. Okay? It causes an error. Okay? And here's why when we're working with log equations specifically, we really have to be careful, because if I have the log of some negative value, the log of a negative number doesn't exist. It does not exist. You check it with a calculator. You plug in the log of -1. It'll tell you domain error. Well, let's prove it. So let's do the log of -1 equals something. Let's prove that this doesn't exist. Bring your base out of the basement. 10 to what exponent will give you a -1 result? Nothing, right? It doesn't matter what this exponent is. This number can't even equal 0, right? So when you have the log of a negative, this is the situation that you are creating, and those situations don't exist. So just remember that. Also, you always want to be on the lookout for the type of log equation that you're solving. This one's the most simple type of logarithmic equation that you can solve, because you have logs and a 0. Okay, so anytime you have the situation where you have logs and this 0, which is your non-log, but it's a 0, okay, you can apply property 8 that says if I have the log of some number, some base of m is equal to the log of some base number to the n, if logs of numbers are equal, then I can replace that with m equals n. So if I can convert this equation right here to look like that, can you see it? Can't I just add this log to that side? Then I can apply log property 8 and just drop the log part of the statement and set the log numbers, the numbers equal to each other. So we're going to use this. So that's the conditions. Did you get the conditions? You got logs and a 0. Put a log on each side, drop the logs. So that's what we're going to do. So we're going to add the natural log to that side. So we have the natural log of 3x plus 2 is equal to the natural log of 2x minus 3 plus 0. I don't need to write plus 0. So if I can create that condition, I have made this a lot easier on myself. So since these logs of these numbers are equal, then the numbers are equal. And I can solve that basic linear equation very quickly, subtracting 2x from both sides, subtracting 2 from both sides, right? We get x equals -5. Okay. So before we walk away from it and say that our solution is -5, we have to make sure that when we plug this -5 in here, we don't create a situation that's restricted. So we're going to do our check. Are you ready? The natural log. You guys have room over on the right, I think. Okay. So the natural log of 3 times -5 plus 2 minus the natural log of 2 times -5 minus 3 should equal 0. Okay, so let's simplify that. That's the natural log of -13. Whoa, I put on the brakes. That does not exist. That is a restriction. I'm going to finish the problem. However, I am going to start marking this out with my red pen. Over here, I get the natural log of -13. Now, the reason that I finished that out is if you look at that, that looks like a true statement, right? Because it's one thing minus itself equals 0, except it's a thing that doesn't exist at all. So it can't cancel itself out because it doesn't even exist. So we have to be really careful. I'm getting out my red pen and I'm going, does not exist. Therefore, my solution is extraneous. And there is not a number in the whole universe of real numbers that's going to make that a true statement. It's just not going to work because logs of negatives do not exist. Questions about that? Okay, so you notice that I did not write my solution until after I checked my solution to make sure. Okay, you try. Okay, so check your work there. We have the answer 1. We plugged the answer 1 in. It did not create the restriction. We had log of +7. So we could then accept that the answer 1 is not restricted. Therefore, it is our solution. Okay. Now we're going to move on to example 2, which is going to require a different strategy because I cannot rearrange this problem so that I have a log equals a log. I have a combination of logs and this non-log over here, this number 1. And so we are going to have to do a couple of things to solve this. So what I'm going to do is give you some steps that you can follow as you're practicing these types of problems that are this condition. Okay. Step 1, when you have, you know what, let me write this, combo of logs with non-logs. So I'm going to write that down. So these are the steps or these circumstances or these conditions. Step 1 is you want the logs on one side and the non-logs on the other side. So if it's not that way, make it that way. Step 2, what you want to do is condense your log on the left equals your non-log on the right. So now we're just working on the logarithm. So it goes from 2 terms or 3 terms or however many terms it is, condense it to a single term, and then you're going to convert to exponential form. And then step 4 is you solve and check. And this is good advice for most problems like this. We may run into some on Monday where we might have to employ a different strategy, but for today, this will work. Okay, so here we go. So I look at this problem and it's a combo, logs and a non-log. That's not a 0. I also know it's a base 10. That's helpful. I like doing my base 10s. 10 to the 1, 10 to the 2, 10 to the 3. Yeah, just, 10 to the 1 equals 10, right? And 10 squared equals 100, and 10 cubed equals 1,000. So this is 10 to the first power when I do my conversion in a little bit, because these are base 10, right? And if it's a 2, it's 10 squared. And if it's a 3, the non-log. Okay, so just be aware that this guy over here is your exponent. This number over here is your exponent, because that's what logs are. Logs equal exponents. Okay, so let's condense, because we have already, step 1 is already taken care of. So step 2, condense. So what property allows me to combine these two separate logs into a condensed log? Multiplication, right? Right? The log of a product is equal to the sum of logs. We're just working it in reverse. So the sum of logs is equal to the log of a product, equals 1. So that's step 2. I'll color code that. That's step 2. Okay. And I'll go to step 3, where I'm going to do my conversion. So now that I have a log equals a number, I need to convert it so that I remove the log from the equation. So what's my base? So I'm going to go 10 to the first equals, right? Bring the base out of the basement, and those two things are switching place. So 10 to the first is equal to x times x minus 3. Now it's just a quadratic equation. We'll factor it out. We'll find our zeros. We'll check our solutions. So we've converted it into something we can handle. So now we have x squared minus 3x equals 10. I'm just distributing and rewriting it in the order that I prefer. You okay with that? Everybody? Oh, I'm on step 4 because I'm solving now. Okay, and then I'm going to incorporate the 10, make it equal 0. So x squared minus 3x minus 10 equals 0. Subtracting 10 to the other side. And since it's quadratic, we'll try factoring before we try the quadratic formula. So we're looking for our factors of negative 10. That will add to negative 3. I think negative 5 and positive 2 would work well. Correct? So either x minus 5 equals 0 or x plus 2 equals 0. So x equals 5 or negative 2. Now, before we say those are our solutions, we have to make sure that neither of them create a restriction. So we'll do a check with the 5. I think I'll check it with purple. Okay, so check. So the log of 5 plus the log of 5 minus 3 equals 1. So I'm going to go through the same process. Of course, you could plug that into your calculator. Your calculator will tell you that it's true, but we'll just write it out. So I'm going to condense this just like I did here. I'm going to write this as the log of 5 times 2 equals 1. Right? 5 times, that's a 2 right there. So that's the log of 10 equals 1. Isn't that true? Log base 10, if the log and the base are the same, the answer is 1. And you know it because 10 to the 1 equals 10. So we can come over here and say, okay, 5 is a good answer. 5's good. And then I'll check the negative 2 with blue here. So I'm going to do this. The log of negative 2. Stop. No. Does not exist. Is no good. I can't have the log of a negative number. There's no need to plug it in anywhere else. It doesn't exist. Therefore, wrong color. 5. I want purple. Thank you. Is your only solution. Negative 2 is a restriction. It is extraneous. We must not include it. Okay, you try. Okay, so there you go. There's your solution. We checked 20 and negative 5. 20 worked. Negative 5 didn't work, so our solution is 20. You're doing problems 29 through 39 on your assignment. It is due on Monday.